Hello everyone, my name is Emily Helena, my supervisor is Matthew Gusdile, and this is a demonstration of KiaiTime, a mixed initiative PCGML rhythm game editor for the game Taiko no Tatsujin. Both me and my supervisor are members of Grail Lab at the University of Alberta, and this work is sponsored by the Natural Sciences and Research Council of Canada. The game domain of this work is Taiko, a long-standing rhythm game franchise that's been around for about 20 years or so now. In the game, players hit a predetermined series of notes to the beat of a song, known as a chart. As you can see on screen here, notes come down the timeline to this little reticle, and this player will hit them in time with the drum to the song. The goal that we're focused on is how do we help humans create charts better with the help of AI partners or algorithmic means. This leads us to our tool. KiaiTime is the first AI-enabled co-creative rhythm game editor. In the tool, a human user and an AI assistant work together to create a chart for the game Taiko. You can see the UI of the tool up right now, but we'll get back to this in just a minute when we'll see it in action. You might be wondering, why do we need KiaiTime? Well, for starters, the population of players for Taiko is much greater than the population of authors. We're talking 15 million users to only about 1,000 authors of charts. And that's not just because of lack of interest. Making charts is hard. It takes specified design knowledge, and even once you get good at it, it takes a lot of time to create an individual chart. Notably, there are no other co-creative tools like this for rhythm games, so this is pretty much uncharted territory. So what did we do to tackle this problem? Well, we created the first co-creative AI rhythm game editor, utilizing pre-existing Taiko chart generation technology that was tweaked in order to work in a co-creative context, as well as creating a new method of designer adaptation, which we called threshold designer adaptation. More on that in a minute. The interaction framework of our model is turn-based, meaning that user and AI assistant work in distinct turns to create the Taiko chart. Once the human user wants some AI input, they end their turn and select a prediction region, querying the model to fill in a certain area of the chart. Once given the area, the model will return what notes it thinks should go in that allotted area and pass control back to the user. Now that you've got some intuition for how the tool works, let's see it in action. Okay, so here we are in the KiaiTime editor. To go over some basics, there's this big empty timeline in the center of the screen. If I hit play, I can hear the song and it starts to move along to the beat of the song. Each and every one of these ticks is snapped to a specific beat in the song, with each of these big white ones representing the start of a new measure. If I want to place some notes on the timeline, I can do that by left clicking. I've got access to a bunch of different object types, so let's make a little cute little pattern here. Maybe 1, 2, 3, 1, 2, 3. That seems nice to me. Now, if I want to go ahead and pass things off to our AI, see what the AI maybe wants to do, I can hit the Q button, which is the Pass to AI button, and I'll select maybe this region for it to predict over. Let's see what it gives me. Give it a few seconds to chew on that, and there we go. So as you can see, it's given us quite the little mix of both red and blue notes. This ba ba ba, and things are good. So if we want to look at this and we want to keep going, maybe I like this idea that it did here, so I can place these 3 spaced notes just like it did. Say good job, I do like that. Maybe I'd rather this be 5 notes all in a row. And then I can maybe go ahead and query this again for this little section. Let it chew on that, and we get 2 notes. That's a-okay. If we want it to try again, you can always try that as well. And there we go, it fills in more. Now that you've seen the tool in action, here's some additional information to give you insight into the back end of the model. For our data representation, we initially trained on 100 of the top-rated human-authored Taiko charts. From each of these charts, we had some song data as well as some note data, both of which we processed into a vector representation to feed into a machine learning model, which handles our predictions. These sections were processed in 23 millisecond segments, and if you have more questions about them, more details about this can be found inside of the paper. As well, we came up with this threshold designer adaptation method specifically for KiaiTime. Our motivation was finding a way to better adapt from designers. And our method was to retrain a small amount after a certain threshold amount of data is collected from a human user. We ended up comparing this to another naive approach in a human subject study, and we found some interesting results, which will hopefully be coming soon. If you have any questions about that, feel free to ask me. As for this AIDE demo, what you can do is create a Taiko chart with an AI assistant. You get to interact with a brand new AI-enabled tool, and as well, you get to test out this new method of threshold designer adaptation. See how it feels to use. Please give us some feedback about how you enjoy the experience. Thank you so much. Here's my contact information, and I hope to see you at the demo.